Good morning. Is it morning? It's afternoon. Can tell that it's been a very, very short day. I think some people are still walking in, but I think I'll just start with some introductions first. Good afternoon, everyone. And yes, you did see correctly. My name is Ntlantla Kinkosi, which does mean that I have two names that mean the exact same thing. Yes. It seems to run in my family. My mother is named Nomathemba Faith, which also means the exact same thing. So I don't know, naming things seems to come quite naturally to me. When I'm asked what I do, I often struggle to answer this because in true neurodivergent nature, I really enjoy doing a lot of things. For starters, for my job, I work for a company called BBD. BBD is a bespoke software development house, so we build custom solutions. It started 41 years ago in Sandra's garage in Johannesburg, and we've now grown to be a global company with around 1,300 staff now, operating Joburg, Cape Town, Pretoria, London, India, Portugal, quite a few places across the world. And we really do software dev, pretty much like a lot of you that are in this room today. But my job at BBD is slightly different. I lead a unit called ATC. Don't ask me what it stands for. I'll give you the PR answer. But what we actually do is that we're responsible for BBD's research and development functions. We do some consulting work. And what really resonates with me is that we are responsible for learning and development across the group of companies, which really fulfills me. For my sins, I studied at WITS. And as the new slogan says, for good, I seem to have Stockholm Syndrome, because I've gone back to teach at WITS. So I lecture computer science there, and I seem to really like suffering. And I've decided to be a student this year at UP as well. So I don't know. Someone please rescue me. This is a cry for help. I am the co-organizer of a meetup called Josie.js, because I really like JavaScript. And I've been involved with a number of other meetups. I think just from this introduction, you'll start realizing that I tend to overshare when I'm on stage like this. And oversharing sort of comes naturally to me. And so in the spirit of oversharing, I'd like to tell you 3 important things about me today. Number 1, I like JavaScript. Like a lot. Like an unhealthy amount. The reason for this varies depending on when you ask me, but I really think at the core of it, it's because when I started learning JavaScript, my mentor at the time was a guy named Mike Geyser. I think Mike was probably one of the first Google developer experts in web technologies on the continent. I know Mike. Mike is awesome, right? JavaScript wizard, absolutely. So he taught me JavaScript, and I think his passion for it sort of like rubbed off on me. And this is why I'm just as passionate about it. But my colleague at the time, Jerry, once said this to me. She said, I like JavaScript because it's broken, and I can relate to that. And the older I get, the more I realize that this is the true reason why JavaScript resonates with me so much, right? It's so broken, but the people that write JavaScript love it so much. So the first thing I told you is that I like JavaScript. The second thing I want to tell you is that I don't like apps. The third thing is that I really like JavaScript. But let's zone in on that second one for a bit. Why do I hate apps so much? I was thinking about this last week, and I realized that one of the first cell phones I ever owned was a Samsung S4 Mini. While it didn't blow up, it did die with me rushing through the airport, trying to get through airport security. It fell, screen didn't crack, didn't break, nothing, it just went quiet. But before it died, it started giving me these messages. Anytime I tried to install an app, I'd have to go back and try and delete everything. And even though I've gotten rid of everything, it will still tell me that I don't have space. Cloud came and told us that these are problems of the past, and yet my iPhone just this week told me that my iCloud storage is full. So storage is something that has always bothered me, which is particularly why I hate it when I'm forced to download apps that I'll never, ever reuse again. Absolutely frustrates me. Single-use apps absolutely annoy me. So recently, we launched a non-profit initiative called Fix Local, where we help you figure out how to report local issues, burst pipes, potholes, you name it. And you're able to go and report it, and if that doesn't work, we tell you how to put pressure on the politicians, including figuring out who your ward councillor is and giving you their contact details right on the app, right? So really, really fun stuff. To do this, we built this entirely as a web application. So when the person who's driving this put the slide up during the launch and said the next step involved us building the app, I was utterly flabbergasted. What do you mean we're building an app? This thing works absolutely perfectly. We don't need an app. And every single time I go on a rant about how awful apps are, my colleagues try and tell me about these important things, security, blah, 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 all these important points. This is all to say that I am very, very interested in how we can make the web almost indistinguishable from native applications. So I'm particularly interested in the tools and abilities that help us achieve this. But why haven't we until this point? It's largely because of risk, right? Because for you to deploy an app, you need to get a license for iOS development. You need to be a registered entity. Your app gets vetted, gets checked, which means that the chances of an app being malicious are slightly less. Not zero, but less. On the website, the Wild Wide Web, right? Anyone can deploy anything, and that's how a lot of people end up losing their data. And so the web has sort of been like sandboxed, or the browsers have been sandboxed, so that malicious websites don't just get all of the access to your machines. But, as my man Jeff once said, any app that can be written in JavaScript will eventually be written in JavaScript. So today I'm going to touch on a few APIs that I find interesting, that I think people need to consider more and should be using more. I've seen some of them in some instances, but I don't think I'm seeing them as much as I expected to. So first we'll cover very briefly the file system access API. We'll go through how we can fetch data in the background without blocking your main thread, without your browser tab closing, canceling your downloads. We'll look at how we share content using the browser. We'll look at how to pick contacts from our phones. And then lastly, if time permits, we'll look at how we can interface with the GPUs that are running on our system straight from the browser. The thing about discussing closing the gap between native apps and web apps is that the conversation is always limited to just the mobile experience. This is particularly important for us in Africa because almost 75% of web traffic happens through mobile devices across the continent. This is absolutely incredible. But if we consider the fact that some countries in the first world still heavily rely on desktop applications, it means we need to ask these questions for the desktop as well. But more so, a lot of our business type applications are also moving from native apps and running in the browser. Examples include the Office 365 suite. In fact, you get to pay more for licensing that allows you to use the native apps. It's far, far cheaper to get a license that runs in the browser, which means we need to start asking the same question. Because, OneDrive. As I was creating this talk, on this machine, I probably have about 5 different copies of these slides. Because every time I try to find it, it would somehow be in recovery mode. And this is not to dunk on OneDrive, right? Absolutely love it. But the point here is that sometimes you actually don't want to connect to the internet in order to access files from your machine. If I have the file on my machine and my web browser needs this file, or whether it's a CSV file that we want to edit in our application, whatever the case is, I should have a simple way to access that file on the machine without needing the internet. A typical user flow would look like this. You would ask your user to upload a file, you'd read that file, you'd put the data on your screen, you'd allow them to change it, and then once they're done, you would then probably export it, right? This is a very obscure user flow that we web developers are very comfortable with, but it's actually not user-centric. So the first API that I want to talk about tries to solve this problem. It's called the File System Access API. And really what this API does is that it gives us the ability to access a user's files and directories that are on their machine without the internet, straight from the browser, right? This leads to enhanced user experiences, and if you're building progressive web apps, it means that your offline capabilities are just that much more robust. And of course, if you don't rely on the internet, it means that you get immediately performance enhancements. To achieve this, it gives us a couple of functions or methods that we can rely on, such as the open file picker, save file picker, and this is to say it uses the native operating system's file picker, which means that all of your fancy designers can stay away from designing what file pickers look like, right? Means that they don't give you spinning kick, flying UIs where the user now needs to figure out what's going on. It's reliant on those baked-in OS interfaces. It's secure by design because the user needs to trigger that, or the user needs to trigger that action using gestures. They need to actively click on a button. They need to actively give you permission to read that file, to save that file again. And of course, it's served over HTTP only. Let's look at a demo of what that actually looks like. Let's see, do I have a browser open? I've got a, don't ask why I was Googling irresponsible AI. I'm going to open up a demo that's running on my machine. Actually, let's look at a deployed version. DevConf 2025. There we go. So I've just deployed a very, very simple website. We'll look at the first one, which is our Web File Access API. And what this means is that I'm now able to open up a file that somewhere on my machine will open up this demo. That's a massive resolution screen. That's incredible. But what I'll do is that I'll put VS Code right next to it so that you can actually see it running. So let's just put those together. And we've got our web page and we've got our demo. What I'll do also is that I'll put up the actual file itself that we've got in there so that we can actually see it change while it's changing. This was demo 1, so I'll just drop that in there. Did I open the correct file? It's just open file. Does that say demo 1? Thank you. You are my eyes in my old age. Which means that if I'm able to change this, right, by simply pressing save, it actually saves, asks me for permission, and when I save those changes, it actually goes and changes it in the actual file on my machine, which means that I can do this offline as well. So I'm not changing some text and exporting a file, I'm actually changing the file that is directly on disk, directly from a browser. Which means that even if this page, we access it without any internet, so if I go application, or network rather, and I throttle this, if I can find the throttle, there it is. So if I take this page offline, I'm still able to open a new file. Let's see if that's cached. Let's hope it's cached. It's not. Let's bring back the internet a little bit, just for a bit. So it means that there, it means that even though this goes offline, I'm still able to actually work on a new file or open up the existing file that we have. So that's still demo 1. I can go and change all of the text in there and save it without having any internet access at all. And there we go. So we now have full access to our actual file system without needing to connect to the internet, which really starts opening up itself to a new range of applications that we can build in the browser. This API is really cool, but it's currently only available on Chromium browsers, but there's plans for all the web browsers to actually build this into their offering. So expect it to start coming out very soon. But remember, it's important to share. So we've got our content, we have our web pages. How do we actually share content using browsers? The typical use case or the user flow is that we would take our URL, copy it, we'd paste it in WhatsApp, paste it in Teams, or a similar workflow. All the while native applications can pop up this common OS level share sheet, where the user can choose that they want to share this via and which app they want to share it by. The next web API tries to solve this problem. It's called WebShare. WebShare allowed us to start putting all of these fancy share buttons on our social media with all of these different links. And what it allowed us to do was to be able to share the URL, a text, a title, as well as what body of text we actually want to pass along. It means that if we take a look at our Android OSs, it means that for the first time, we could now bring up the share sheet directly from web pages. This has been available since around 2017, and the code for it is actually quite simple. We use the navigator object or the navigator property, we call share, and we pass in the three things that we need in there. What this enabled is for websites like YouTube, when you click that share button, it would bring up all of these different targets. And the different targets are there because each target will actually handle the share differently. If you share to LinkedIn, for instance, it would simply put up the holding image or the thumbnail for that video on YouTube. But if you actually post it to X, formerly Twitter, it would discard all the content you gave it, paste the link, paste the title, and Bob's your uncle. Because they rely on the fact that after you post it, then only will they fetch that thumbnail. This is all good and well, but it's not really the best we could do. And so, on the premise that sharing files in a web browser should be simple, straightforward, and intuitive, we came up with a new version of that API. Because we're great at naming things, we called it 2, right? So this is the Share API Web Level 2. And the big distinction here is that for the first time, we can share files directly. Which means if you're building a spreadsheet or you're generating a PDF or you've got a document on your browser, if you're behind some sort of login or you're behind some sort of page that you don't want other people to see, all you want to share is the document, such as WhatsApp. If someone sends you a document, you can click on that document and just share the document. We can now do that directly from the browser, relying on the operating system level configuration, which means we can bring up share sheets as we know them and start sharing it. Relies on the native UX. It leads to simplified development, and of course, it means that you can share your content across all the share targets that a user has on their machine. Conversely, it means that you can register your app as a share target for specific share types so that a user can share those documents to your app as well. To do this, the data object in navigator.share has now been modified to accept an array of files, which means you can send multiple files all in one go. The user still needs to trigger the gesture, and it must run on HTTPS. And for our second demo, let's see, I'm on a MacBook. Does anyone have an iPhone in here? iPhones? Yes, iPhones? Cool. If you turn on your, what do you call the share thing? AirDrop. Yes, that's what we call. So you see that now, when I click on share, what it brings up is the actual native UI. If I was on a, not MacBook, what's the other one? I almost said Android laptop. The laptop version of Android. Windows, that's the one. If I was on that, that would be different. But now we see that if your AirDrop is on, I don't know who's brave enough to accept. I promise it's just a text file. There we go. We've got Lozi's iPhone, Jay's iPhone, Shadi's iPhone, Yashu's iPhone. Let us know if you receive this text file. Received. One more? Received. There we go. Which means that directly from a web page, we can now share using the operating system's interface directly, leading to a much simpler and actually a bit more secure workflow. This API is well supported. We see it in almost all of the browsers, including Safari. Yay, well done, Safari. And you'll notice that in Android's WebView, they don't support it because they already had something similar for Android developers called Web Intents, right, or Intent URL, which means that this is something that's available in all of your browsers pretty much today. Speaking of sharing, how many of you have heard of PDD? Not this one. But this PDD. Pinduoduo. Any hands? None of you? This is the third largest e-commerce company on China's stock exchange. You might not have heard of them, but Pinduoduo has a product that I'm pretty sure all of you have heard of, called Temu. So PDD is the parent company of Temu, and they were largely successful in China because of something they call social buying, where they allow users to buy as a group, as a collective, and get their things delivered to one, which means that we can create a joint cart and we can pay for it individually, and then it all goes into one giant pocket. That's understood to be one of the true powers that they bring in, and it's predicted that the Temu app is likely to start relying on features like that in order to grow their market base. This all says that the ability to get a user to share contacts with us becomes increasingly important, because it's a really good and intuitive way to fill in forms, to grow our user base. And until now, doing this on the web has been very, very challenging. All while the native applications can just say contact picker, and then a user is able to pick the contacts that they want to share with you. So the next API is called the Contacts Picker API. It's a privacy-preserving way that leads to improved user experience, because they can just pick the information that they want to share with you, and it uses the native operating system's UI, which means that it's an interface that your users are used to and one that they trust. Here's a demo of it. I can't demo it because this API is currently only available on Android phones. I did have an old S4 Mini though that I could spin up. And this is what it looks like. On this page, you're able to select your contact. So if you do have an Android phone, I'll put up that link to the demo afterwards, and you can check it out there. But what it does is that it pulls up a drawer for you to pick the contacts that you want to share. As the web page, you configure the fields that you want to get. So for this example, I ask for the profile picture, the names, I ask for the phone number and the email addresses. But a user still has the ability to pick which of those fields they actually want to share with your web page. And once clicked, you can then get the data and do with it as you please. I had to gray out some of the stuff there because my colleagues' phone numbers were there, and I don't think they were happy. I thought they'd be here, so I was scared that they'll throw tomatoes at me. This API is not as well supported because it's very, very new. Currently, it's only Chrome, Android that has it, but there's plans by pretty much every large browser manufacturer to actually bring this to their browsers. So expect it to start coming up, right? This feature is really, really cool, and I think it's going to unlock a lot of new ways of us reaching new users in our ecosystems. What's absolutely funny is that as we talk about the future of the web, it seems like we keep going backwards to try and fill the gaps that JavaScript or that the web couldn't fill because of security issues, because we've learned new patterns and we're able to do new things. How cool is this picture? Look at this one. This is AI generated, by the way. I absolutely love creating images like this, but the problem is they're so big. AI image generation at the moment is still generating very, very large, massive files, which brings me to my next frustration with the browser. Downloads. As a student, I sometimes source my content from alternative sources. And I've seen this sign many a times. We've all been there. You open up a tab, you accidentally close it while the download was still running in there. It happens to all of us. And with my age advancing as it is, this is a common problem. Actually, while preparing for this talk, I tried downloading this video through an alternative site that can download videos for you from any other site. And they had this text that said, please don't close this page until the download starts, right? This all speaks to this issue of needing to babysit a tab just because it's downloading. We see all of these large language models. They're so big, getting them on your machine takes time. How do we solve the problem of needing to keep a tab open or babying that session? How do we deal with a network dropping and making sure that our download or upload doesn't fail? We have something called the background fetch API. Now, the point of this API is to help you download or upload things that take much longer in the background, allowing your user to close the tab, continue browsing as they wish. When the network drops and they come back and the network picks up again, for the download or upload to continue. YouTube currently does this really, really well. As soon as you get through that first threshold, they'll just keep running your upload in the background. What it looks like is pretty simple. It relies on the service worker firstly, so that's where all that magic is, because you simply offload all of that workload, that fetch, into the background by letting the service worker do it. So all you need to do is register your service worker. After you register it, you then kick off a background fetch. You kick off a background fetch, rather, and what you need to give it there is the link. So where's the URL for the resource that you're looking for? And then you give it some information about how you want it to show the download icon on the top right-hand corner there. The cool thing about this is that it will send you messages on updates. It'll tell you, I've got more chunks of data available. It'll tell you that the fetch has completed. It'll tell you whether the user has aborted the fetch, and when there was an error somewhere, it will also announce that. So you can simply add an event listener and action on those different events where necessary. The cool thing about this is that if you go offline, you are now able to continue that download, continue that upload, which is critical, especially for use cases across the continent. We have vast spaces between our critical centers with infrastructure, which means now we can actually build offline capable progressive web apps that allow users to download all the data they need for the day, go out into the field, do their field work, come back with the data, and then the upload continues. The other cool thing is that you can trigger uploads and downloads while it's offline, and then the service worker will then action them as soon as it gets onto the internet. This has proven to be the most tricky demo, because finding a fast enough or finding a big enough file that isn't spyware has proven to be quite challenging. But let's see if I can show you. So we've got the background fetch API, and what I've done here is that there is a resource. It's a tiny AI model from Google that I'm trying to download here, and then I'm caching it in my IndexedDB. So you'll see that when I start my download, there it is. Man, that was fast. Let's see. That was way faster than I anticipated. Let's do that again. Wait, I know why. I changed it and didn't deploy. So I'm going to run this locally. There's my background fetch. I'll just run live server. Oh, it's running already. Let's go localhost 5500. Does that say 55? Yeah. It does, thank you. What would I do without you? Cool. Struggle, yes, absolutely. Which means that over there, I'll just open up my console. If you see anything red, just pretend it's not there. But it means that I can kick off this long fetch, right? And we can see that the data will start streaming in, and we can see that it's updating, and then I can just close that tab, right? So the tab is gone, but the download is actually still happening in the background, which means that when I reopen that page, we should see that it's actually still continuing, and the download is actually still running, right? Means I can terminate this page, and hopefully, in the next 3 seconds, maybe, hopefully, with prayer, maybe, the download will be done, right? But if not, this also allows, there we go, right? So what we've downloaded isn't text, so I can't really show it here. I couldn't find a large enough text file. But it means that a user is able to continue their workflow, and we still rely on that native UI to actually show us that that download is done for the download purposes. With uploading, this is absolutely incredible because we can now keep track of this. So all of this data that you get there, we can save it in our cache API, in our IndexedDB, and then we can read from it when we need that data. So this now starts allowing us to build truly, truly offline capable web application directly from the browser without needing to skip around. API, browser support for this is fairly okay-ish, not where it should be. So we do still have the likes of Firefox that are currently still working on it, but it's widely and stably available on Chromium browsers, so Edge and Chrome, and it's also supported by Opera, and so it is going to be widely available for most people. Again, the magic here happens because of our service worker, and this means that we have much more reliable downloads and uploads, improved UX, and resource management. But it also means that we free up the main thread, allowing us to build the much more interesting user experiences that we want to give our users. Experiences such as this. What you're seeing is actually running in the browser. This is rendered in the browser using the canvas. And each of those waves are a lot of data points that need to be downloaded to your browser. So while the background fetch API can help you with that, computing each of these waves is difficult, What you're seeing here is that the data is saved as spatial data, and then using a fast Fourier transform, it's then converted at real time or at presentation time to figure out what the height of those waves are. So instead of doing the addition using point position data, we do it using spatial data, which is way less computationally expensive. And we're able to render this because of our ability to calculate better in the browser. This sounds like the job of a GPU, right? Being able to deal with a lot of calculations in a very short amount of time. Remember my friend Jeff? Jeff said JavaScript will eat everything. And it's not new, right? TensorFlow.js was described as a WebGL-accelerated, browser-based JavaScript library for machine learning. You know, every time I think of JavaScript developers, I just think of a community of just like tinfoil hat people trying to build and eat up absolutely everything they can get their hands on. But the more interesting thing about this definition or this description of TensorFlow is that it's WebGL accelerated. What does that actually mean? Well, it means that TensorFlow is able to do what it does because of WebGL, which was released in 2011, and it gives the browser the ability to use the GPU. So it gives it an adapter and a couple of APIs for it to start tapping into the GPU so it can offload some of those calculations. WebGL was cool, but in that time, GPUs themselves have advanced so much that we needed a new way of interfacing with them and making it simpler. And that's where WebGPU comes in. So WebGPU effectively is this adapter layer that makes it easier for us to connect with the hardware. The cooler thing is that it also has APIs that allows us to interact and use even external GPUs that we can plug in to our devices, which means that machine learning and all of the AI craze doesn't leave JavaScript developers behind. This is a demo from Babylon.js. What you see is a 3D rendering of a gallery. And in this gallery, you'll see that the frames per second is running at around 526 frames per second. This is running on WebGL. The same demo built using WebGPU sees significant improvements. This version now runs at about 8,000 frames per second, which means that we're seeing performance improvements 10, 11, 12 times that of what we had when we just used WebGL, which means that just using the APIs and the way the APIs utilize those resources gives us insane improvements. The WebGPU promises and fulfills. See what I did there? Promises, JavaScript. I'm here all day. It promises it promises a JS-first approach, meaning that all of the things that you're used to in writing JavaScript, you can use those same patterns. It promises reduced state management with a much less chatty API, meaning it only gives you messages that are necessary, as opposed to the previous one that streamed every bit of information about everything that was happening to you. It claims to have improved error management, allowing you to really debug GPU usage even better. Demoing this is a little bit trickier because I'm actually really bad at designing things. So I did the hello world of graphics, which is just blink a UI. If I click this and the screen turns blue, it means it works. You just have to trust me. So there, did we see that flash? Woo! To prove to you that I'm not just lying to you, if we run the exact same demo on Firefox, it doesn't work because Firefox doesn't yet support the WebGPU API, right? Which means that what we're able to do here is actually connect to the WebGPU and ask it to render this color for us. This took about 100 lines of code. I think if I can find the demo over there, yeah, let's say 100, give or take, right? And this is just a flash. But it does mean that when we need to build much richer or more computationally expensive things, we can now start doing it. Because remember the tinfoil people, we don't get left behind any craze, including AI. While prepping for this talk, I decided just to check if there's any updates on AI from the Chrome dev team. And I saw this. It says AI on Chrome. So I have a really sneaky suspicion that we're going to be training AI models in the browser very, very soon, right? There's a couple of projects that they seem to be working on, and I think JavaScript is still going to be very interesting in the space. We've covered quite a bit of ground. We spoke about the file access system. We spoke about fetching things in the background, sharing data. We spoke about picking our context so we can share things with, or so that we can get their information and spam them even more. And we spoke about the WebGPU API. This is not an exhaustive list. There are a few more interesting ones that I think are worth keeping an eye on. My favorite is the Web NFC API. You know, I can't wait till I can accept your Apple Pay payments on my crappy website, so I can just walk past you with my website and get some of your money. And there's a few more, and these are all being driven through a project called Project Fugu, which is a multi-organization initiative that's focused on bringing new capabilities to the web and making sure that we close that gap. Their statement says web apps should be able to do anything iOS, Android, and desktop apps can. It's a very ambitious initiative, but I think it's a really, really cool one. 2 nights ago, I looked at some of the newer requests that have come in, and the most interesting one that I'm keen on is the Health Connect API, which is going to give you access to all the health data that you have. That's very sensitive data that people have been very iffy about, but I think there's finally consensus on how we can do this safely. So I expect that one to come. I also particularly like web biometrics. I've had to build the biometric system for one of South Africa's banks about 7, 8 years ago, and it was a nightmare. So being able to access these devices much, much easier and quicker on the web is something that I particularly look forward to. This is all to say these APIs are constantly changing. And if there's one thing you take away from today, is that the only way you'll be able to build killer user experiences is if you keep playing with the technology. My final thoughts, you can't take this in one shot and say, everyone stop what you're doing, we need to implement the context API. You need progressive implementations, use these APIs where they work. If you're doing an HTTP call just to get a list of books, you don't need to do it in the background. You don't need a service worker. Just use fetch as it is. But if you really have the use cases for these APIs, you should really consider them. Stay updated. Check caniuse.com, because you can't ship a feature that most of your users can't actually access. And lastly, in everything that you do, always keep your user first and make sure that you're building experiences that matter to them. My name is Lucky Nkosi. Thank you very much.